Well, here's a question for you. What do you think about when somebody says the word silver? You think about jewellery, perhaps? Some old silver coins, fancy tableware, maybe? Well, indeed, silver can be all of these things, but it's actually also a very important industrial metal. And even more so now that the energy transition gathers pace, because silver is a key component in solar panels. So let's have a look in more detail as to what silver is used for and where it comes from.
Silver is one of the precious metals, together with gold and the platinum group metals. Silver is a popular metal in jewellery, and it was historically used as currency too, but it has many properties that also make it a very versatile industrial metal. Silver resists corrosion and oxidation, it's very malleable, and has the best electrical conductivity and thermal resistance properties of all common metals. Pretty much all electronics rely on silver, and almost all of our everyday electronic devices contain some silver. Your mobile phone, TV, LED lights, cameras, watches, and so on. Silver is also non-toxic and antimicrobial, which is why it is used in medical applications such as dental fillings and as coatings for surgical tools.
And perhaps most importantly, for today's problems, silver is really important as a key component in solar panels.
Silver has very high reflective properties, which is why it is not only used in mirrors, but also in photovoltaic cells, which are a key part of solar panels. Recent technological advances have meant that the amount of silver needed in solar panels has reduced, but it is still a key metal for the construction of photovoltaic cells. Recent research has also shown that silver could potentially significantly boost the production of hydrogen, which is another potentially important source for cleaner energy. In fact, the energy transition means that the demand for silver is increasing. The World Bank estimated in their report in 2020 that a fast energy transition would increase the demand for silver to build solar power alone by more than 100% by 2050. This puts significant pressures globally to extract more silver. South America is a big silver producing region, with Mexico, Peru and Chile supplying more than 40% of global silver. Other major producers are China, Australia and Russia, whilst in Europe, Poland is the largest silver producing country.
But where in the geological environment does silver occur? I'd like to start with a real life example. I'm here in southeast France in the Haute Alps, and there's an old silver mine here that we can go and have a look at.
The old mining town of l'Argentière near Briançon is the home of a number of small mines that were historically mined, mainly for lead and silver. I'm starting by visiting the mine museum on the north side of the town. Here you can learn about the history of mining in the region and look at some of the ore samples. You can also book onto a tour to the largest of the mines in the area, the Fournel mine.
So just above the town of l'Argentière, you can actually go and visit the old lead silver mines. So let's go and see what we find.
The mine has been intermittently in operation during various periods historically, from the medieval times to the early 20th century, when it finally closed in 1908. The mine reached down to 150 meters below the surface. I've booked myself onto an underground tour of the mine. The tour is 600 meters long and goes through 2 exploration levels showcasing various stages of the mining operation from the medieval times to more modern techniques. But what about the ore itself?
So the ore here is hosted in quartzites in vein systems associated with an alpine thrust plain.
The ore was mined from the narrow, up to 4 meters wide veined zone in the hard quartzitic bedrock. The main ore was the lead sulfide galena, but this galena contained not only lead, but also up to 3% silver. Other ore minerals were sphalerite, chalcopyrite and barite, but it was the silver-bearing galena that brought in the money. There isn't any exploration going on in the area at the moment, and the resource at the Fornell mine is deemed to be exhausted.
But like here, most silver that is produced today globally actually comes as a byproduct of other metal mining. There are very few mines in the world where silver is the primary product.
Silver does occur as a native element, but it readily forms compounds with a wide array of other elements, forming, for example, silver sulfides, silver tellurides or silver halides. In fact, there are more than 30 known minerals in which silver is a fundamental component. About a quarter of global silver is obtained from primary silver ores, but most silver, almost 60%, is mined as a byproduct of base metal ores, most importantly lead ores like at Fornell mine. Lead ores are made out of the mineral galena, which consists of sulfur and lead ions arranged in a cubic structure. If there is silver in the fluids from which the galena precipitated, quite often some of the lead is substituted by silver and another trivalent cation, such as antimony or bismuth, in a process called coupled substitution. This process is so common in galena-bearing ores that the silver, and sometimes the antimony and bismuth, can in many cases be extracted as a byproduct.
Apart from galena, there are many other things that can also host quite a lot of silver.
Substitution processes can also operate in zinc and copper sulfides such as sphalerite and chalcopyrite, so that these too can contain significant amount of silver. In fact, about a quarter of silver production globally comes from mines where copper is the main ore. And there are many other base metal sulfides too that can be sources for silver, such as the nickel sulfide pentlandite or the cobalt sulfide cobaltite.
And then there is of course gold. Because gold is almost never pure gold. It very readily forms an alloy with silver.
About 15% of the global silver production is from gold ores. Gold-silver alloy, sometimes called electrum, can contain pretty much any amount of silver. The silver content in the alloy is controlled by the physical conditions of precipitation and the composition of the fluids that transported the metals. But broadly speaking, gold that was precipitated in hotter conditions, often deeper in the crust, contain much less silver than gold that was precipitated from cooler fluids. So what about the geological setting then? Because silver occurs not only on its own, But as silver minerals or within various base metal sulfides, you can basically find silver in almost any ore type and geological environment. Silver that is incorporated into base metal sulfides is usually associated with basin-hosted sedimentary lead, zinc and copper ores, with volcanogenic massive sulfide ores, or with ores associated with porphyry intrusions. Silver in gold alloy is found in pretty much all types of gold deposits, which in turn form in a wide range of settings, from magmatic intrusions to basins to orogenic gold associated with shear and fault zones. A lot of native silver and silver minerals, on the other hand, come from epithermal deposits. These are often associated with the distal parts of a magmatic system, so associated with hot acidic hydrothermal fluids near Earth's surface. So as you can see, the ore deposit types in which silver is found cover pretty much every geological environment on our planet, from extensional basins to subduction zones and mountain belts. So silver, being a versatile metal for humans, is also one of the geologically most versatile metals. But its production is still largely dependent on the demand for and mining of other metals. So that was a summary of the uses and the sources of the precious industrial metal silver. Hope you enjoyed it, and thanks for watching.